start with something wild. Imagine a civilization, like way beyond us. They've figured out mind uploading. I mean, really figured it out. Digitizing consciousness, encoding it right into space-time. And they want to expand across the galaxy. Sounds almost magical, doesn't it? Pure sci-fi. But okay, let's unpack this a bit. You'd think, well, if you're just information in space-time, you're free, right? No limits. Turns out, maybe not. Even with that kind of, godlike tech, the basic rules of physics, they still seem to apply. Some surprising speed bumps.
Yeah, it's really counterintuitive. You imagine escaping biology means escaping limitations.
Yeah.
But our deep dive into these ideas, these sources, it shows that even for them, some universal laws are just non-negotiable. So our mission today is really to explore those fundamental constraints. The resource limits this incredibly advanced civilization would still slam into.
Right. So with this mind uploading, let's start at the beginning. What's the very first hurdle? Like before they even think about going interstellar?
Well, the first big bottleneck, maybe surprisingly, isn't distance. It's just one single mind. The sheer amount of information in a consciousness, we're talking potentially petabytes, maybe exabytes, for just one individual.
Wow.
What's fascinating here is this thing called the Bekenstein bound. It's a fundamental physics principle. It sets the absolute upper limit on how much information you can cram into a region of space with a certain amount of energy.
An upper limit. Okay.
So to actually write that mind data into space-time, basically, messing with its geometry needs energy, a lot of energy. We're talking potentially a significant fraction of a star's entire output, just for one mind upload.
Just one. So much for uploading to the cloud, then. This sounds more like uploading to a small star.
Pretty much, yeah. It's a massive energy investment up front.
Okay, so that's one mind. But if they want to spread out, go galactic. How does that energy problem scale? I mean, that's got to be huge.
Oh, it scales astronomically. You've heard of the Kardashev scale, right?
Sure. Type I, 2, 3, planetary, stellar, galactic energy use.
Exactly. They'd probably start as a type 2, harnessing their home star, maybe with a Dyson swarm or something similar. But going galactic, that means pushing towards type 3, controlling, or at least tapping into, the energy of the entire galaxy.
And that's 4?
Well, for one, powering the interstellar transmitters. Sending consciousness data streams across light years takes just unbelievable power. And here's the kicker. They probably can't just beam everything everywhere instantly. They'd need to bootstrap new systems.
Bootstrap, meaning?
Sending physical probes first, like self-replicating von Neumann probes. Little robots that travel ahead, find resources.
And build the infrastructure at the other end, like energy collectors, the space-time riders.
Precisely. They need to build the receiving stations, the energy sources, maybe even new Dyson swarms before the minds can arrive.
But hold on. If they are just information, pure consciousness encoded in space-time, do they still need, stuff, physical matter? You might think they're totally post-physical.
That's a really common thought. But the sources suggest not quite. It's a practical thing. Even if the minds are data, the hardware still matters.
Yeah.
The computers, the energy collectors, those space-time manipulation devices.
Have to be built from something.
Right. They need a physical computational substrate to run on to interact with the universe. And interstellar space, it's mostly empty. So they'd still need to harvest raw materials. Asteroids, planets, gas clouds, whatever they find in a new star system. Matter still matters, basically.
Okay, so energy limits, matter limits. What about the universe itself, the vastness of it all? Any cosmic speed bumps there?
Oh, absolutely. The biggest one, the speed of light. It's immutable. The ultimate cosmic speed limit.
Nothing goes faster.
Nothing.
Yep.
So even if your mind data travels at light speed, getting to the next star takes years across the galaxy, hundreds of thousands of years. This inevitably creates what you might call light cone civilizations, branches of this consciousness spreading out.
But becoming increasingly isolated by the travel time.
Exactly. They diverge, become effectively separate civilizations over cosmic timescales, like distant cousins who can never phone home quickly.
Okay, isolation. What else?
Well, this raises a really important question. Information integrity. Degradation.
Like data corruption.
Kind of. Over vast distances and time spans, you've got quantum decoherence, tiny interactions scrambling the delicate quantum information. Stray particles, background radiation, maybe even the expansion of the universe itself could introduce noise.
So the signal could get garbled over millennia.
Potentially, yeah. They'd need unbelievably good error correction, protocols built right into the space-time encoding somehow. It's a huge challenge. And one last thing, the seed probe bottleneck. Sending those first physical von Neumann probes, that's slow and it's dangerous. Interstellar travel is harsh. So the rate at which they can even start bootstrapping new systems is limited.
So, okay, wrapping this up, what does it all really mean for this hypothetical super civilization? Even encoding lines into space-time doesn't give them a free pass, does it?
Not at all. The universe still sets the rules.
Their expansion wouldn't be this sudden galaxy-spanning jump. It'd be slow, methodical.
Very likely, yes. Constrained fundamentally by physics, by energy availability, by the need for matter, by the speed of light itself.
They'd be incredibly powerful, sure, but still kind of bound by the huge, dark, empty spaces between stars.
Right. It really makes you think, doesn't it? How even the most advanced life imaginable might still be profoundly shaped by the universe's built-in limits. What does that tell us, maybe, about the nature of limits themselves? That they might be truly universal no matter how far technology progresses. Something for you to ponder.